Welcome to this session on geometry. In this session, we will take a look at some more properties of circles. The first property is the property when two chords meet inside or outside a circle. So we have two circles and we have two chords AB and CD meet at point P. In the first figure, they are meeting internally inside the circle. In the second case, the two chords meet outside the circle. So we have PA into PB is equal to PC into PD. Similarly, when a chord meets a tangent externally, then say we have a chord AB which meets the tangent PQ, then we have PA into PB is equal to PQ square. Next, we take a look at the properties when two circles meet each other externally or internally. Let's have two circles drawn. So here we have two circles touching each other externally at this point. So the property says that the centers of the two circles A and B and their point of contact C must lie in the same straight line, which means AC plus CB must be equal to AB. Similarly, when two circles touch each other internally, the property still holds true and we have their centers A and B and their point of contact P again in the same straight line, which means AP minus PB, which is the difference of their radii, this is equal to the center to center distance AB. So A and B are centers. Now we take a look at the properties of common tangents. What are common tangents? So the two figures shown here depict common tangents. On the left we have the direct common tangents and on to your right we have the transverse common tangent. Now what we need to know in case of both direct and transverse common tangent is the distance between the 2 points of contact. Now we will take a look at a formula which gives us the answer for the distance between the points of contact in case of common tangent. For the direct common tangent, the length indicated by LD is equal to under root of d square minus r1 minus r2 whole square, where d is the distance between the two centers and r1 and r2 are the two radii of the circles. So the length of the direct common tangent is given by LD is equal to under root of d square minus r1 minus r2 whole square, where d is the distance between the two centers here and r1 and r2 are the two radii of the given circles. Similarly, the length of the transverse common tangent is given by LT is equal to under root of d square minus r1 plus r2 whole square, where d, r1 and r2 have the same meanings as earlier. Now we move to the alternate segment theorem. What does it mean? This theorem gives us the relation between the angle made by a chord, let's say this chord is chord AB, and a tangent at the point of tangency. Let's say the point of tangency is A and the tangent is AT. So the angle made by a chord with the tangent AT at the point of tangency A in one segment. This particular segment that is visible to us here is the minor segment. So what is the angle theta equal to? This angle theta is equal to the angle subtended by the chord at the circumference. So if this angle is angle ACB, then angle ACB must also be equal to theta. So this particular rule or this particular theorem is known as the alternate segment theorem. Let us take another look for the same chord. Suppose we have the same chord AB and say it makes an angle alpha. So we have a chord AB and it makes angle alpha with the tangent AT in the major segment. So the chord will subtend an angle alpha in the other segment or in the alternate segment. So if we have the chord AB subtending an angle at point C in the other segment, angle ACB will also be equal to alpha. So in both these cases, angle BAT is equal to angle ACB. Next, let us take a look at some properties of cyclic quadrilateral. As you know that cyclic quadrilaterals are quadrilaterals all of whose vertices fall on the circumference of a circle. So let us draw one. So here is a cyclic quadrilateral. So in case of a cyclic quadrilateral, opposite angles are supplementary, which means the opposite angles shown here, angle A and angle C, their sum is 180 degrees. And similarly, B and D, which are opposite angles, their sum also must be 180 degrees. So let us write that down here. So angle A plus angle C is equal to angle B plus angle D, and both of them are equal to 180 degrees. Similarly, it also means that if we have an exterior angle to the cyclic quadrilateral, for example, here we have an exterior angle E. This exterior angle must be equal to the remote interior angle. So we can write exterior angle is equal to the remote interior angle. So then we have the Ptolemy's theorem, which states that product of length of diagonals is equal to the sum of product of pair of opposite sides. For example, if we have the two diagonals AC and BD, then to write that down mathematically, we have AC into BD, which is the product of diagonals, is equal to AB into CD, which is the product of one pair of opposite sides, multiplied by the product of the other pair of opposite sides, that is BC into AD. So with this we come to an end of this particular session of circles. If you wish to watch more videos or if you wish to know more about the topic, please log on to our website pfindia.com. If you want to ask a doubt, please write to us at studentservices@pfindia.com. And if you're watching this video on our website, please use the Ask a Doubt feature. Thank you very much.